Okay, so welcome again to another class of material of construction. Here we are going to talk about cementitious materials. So cementitious materials are substances which upon certain chemical reaction attain binding properties. So we have 9 hydraulic cements. These are cements made from gypsum and lime, right? They are 9 hydraulic, and there are cements that are hydraulic cements, that is the or OPC. So most of the time actually you'll see me saying OPC. This means ordinary Portland cement. So ordinary Portland cement, this is actually what we use in the field most of the time. So hydrolysis is that property of gaining binding value when mixed with water. So binding value is that we can say actually covering value. It's binding, right? So it's covering. And these are some properties of cementitious material. We have fineness, normal consistency, time of setting, sun carrying capacity, hardening, and yield. Because these are things that you've learned probably from your material of construction course. And from the Greek word gypsos, that is where we get the word gypsium. Now in here I'll be talking about gypsium from here going forward, and hopefully this video will be less than 6 minutes. So now we have, this is different types of gypsium. And so pure gypsium is definitely calcium sulfate. It has a little bit of water. Now gypsum is colorless or white, but can be tinted light brown, gray, yellow, or green, right? So things that are really important for us. And presence of impurities such as magnesium oxide, aluminium, iron, silica, calcium, magnesium carbonate oxide, right? And so how does gypsum occur? Gypsum occurs as a mineral substance, and then deposits are known to occur in strata. These are forms and 3.8 to 2.5 million years ago. And strata, of course, as we said, there are layers of sedimentary rocks that are below. There's something that we'll also be talking about this in our geology class. And so gypsum almost exclusively occurs in settings where seawater is evaporating, right? So that's where many people get their gypsum from. And so occurrence as seawater evaporates, gypsum is the first salt to be precipitated, following the anhydrite and the halite, and finally the potassium chloride or the slivite, as many people may call. This is a picture of gypsum deposits, and this was taken in occupied Palestine. We don't recognize the state. It's occupied Palestine. And in here, so gypsum in Turkey, because these lectures are found in my from my class in my university in Turkey, that is. So now, so these are places that gypsum are found in Turkey. Business is international audience, you don't need that part. So gypsum as a byproduct, sometimes it's found in byproducts, of course, in Europe and North America from some different companies. And so flue gas, gypsum, and all this. Now these are places that are really important. So calcium sulfate plus this, as you said, this is gypsum, right? You preheat it at this temperature, you get plaster of Paris. This is not complete this is incomplete calcination, right? Plus 1.5 molecules of water, or 1.5 or 3/2. And then when the calcination carried into temperatures above 180, so let's say 195 or 200, you have gypsum anhydrite, right? Now this is complete calcination. Now both these products from gypsum rock, and so by combining with water. So once you combine it with water, because as you can see, what it lost was water. So if you combine it again with water, right, also here, when you combine it with water, now you go back here, it's a reversible process, as you guys have learned it from high school. So a little slow when you had this one, but very rapid, and it hardens in a few minutes, because this thing is in here, this gypsum anhydrite is not actually solid, but now it will harden and it will become solid very rapidly in a few minutes when you add water. And gypsum as a material, so we have lime, and then we have sulfur trioxide, water of crystallization. These are chemical composition with respect to percentages, right? And gypsum hemihydrite, plaster of Paris, and anhydrite. This is their densities down here, as you can see. And so you guys can maybe do this calculation, how much plaster of Paris can be obtained of calcination of ton in here. So maybe if you want to do the question, you may take a pause before show you guys the solution. Okay, since the people are still going, the people who are pausing, maybe you can subscribe, take your time to subscribe. Okay, now 500 kg of gypsum rock is calcined, 320 kg of pure plaster of Paris is obtained. Determine whether the gypsum rock is suitable for commercial use. And this is the this is the, so in here you list these values. Carbon has 40, 16, 32, and I'll do these two questions in our next videos. So where is it used? Gypsum, of course, it's used in tiles, or people use it in tile because of the slower setting time, and some people mix it with gypsum, with sand, right, so that it can be gypsum paste is too sticky to be trolled. So like you can't, this is the process of trolling. As you can see, you guys, I'm sure you know, this is trolling. Now, and the ultimate strength of gypsum, the water gypsum ratio, and if it's high, then amount of water leaving the mixture by evaporating will be high, and more voids will be left behind, and low strength. And so you have to get the ultimate mixture ratio, which is 0.6, and the amount of sand, if it's higher, then lower strength of gypsum, and of course, so there's no point then of you having it, right? And so you have to get an absolute and a better one. So just a quick question: when mixing gypsum plaster, what happens if you add too much water? So if you add too much water, what's going to happen? Maybe you can write down in the comments. You can pause and write down in the comments, but I'll just answer it for you. So when you're mixing gypsum plaster, what happens if you add too much water? It becomes now it stops becoming too sticky, right? And now you have watery gypsum, which you can't use again, so it's become a liquid. Okay, but you need something in terms of a paste. So in gypsum plaster in complete calcination, plaster of Paris, and we say the setting time is this one. The setting time is time that it takes to start hardening. Okay, and okay, we don't need this part. Flooring plaster, calcium sulfate with no impurity, hard finishing plaster, and setting time is 1 hour to 16 hours. Right? The compressive strength is more than 7 megapascal. Gypsum versus fire, or gypsum versus moisture, which one? It is it's actually stronger, and it's resistance to both of them. And this is some overview of some places, Pamukkale in Turkey, and this is about limestone. Now see you on the next class as we talk more about limestone.